this is one of the great showcases, I think, for containers at a more higher level perspective, is that you can start packaging the way you write your apps, and you can start packaging how you release your apps, and you can automate a lot of the stuff in the middle. And so you can really get to numbers like this with, as they said, tens of engineers. About microservices and containers. And then we're going to do just a couple really simple containers for the beginners in the room. Okay? From there, we're going to move on and we're going to talk more about, we're going to talk less about the technology and we're going to start talking a bit more about what Docker actually is and how it impacts how you write your apps. Okay? And some of the superpowers I think Docker gave me. Okay? Who has the group? Can anybody read the thing I put in the group just a couple minutes ago? I like hard numbers. So this was sent to me by a buddy of mine in Beijing that does AI. Right? So
hundreds of microservices, thousands of daily production changes, 10,000s of AWS VMs, 100,000 of customer interactions a second, 1 million of customers, billion of time series metrics, and we do this with tens of what?
Yeah. Okay. So
ups and zero data.
Exactly. So we're talking about literally millions of interactions per second, right? And Netflix. Okay. They've got thousands of production changes per day. So they're using a lot of CI/CD, and they're making changes, and they're deploying those changes to their customers as they're writing them. And this is happening 1,000 times a day, right? And so this is one of the great showcases, I think, for containers at a more higher level perspective, is that you can start packaging the way you write your apps, and you can start packaging how you release your apps, and you can automate a lot of the stuff in the middle. And so you can really get to numbers like this with, as they said, tens of engineers, right? I believe that Netflix has right around 40 DevOps engineers, that's it. And they're managing this like monstrous, this behemoth of a company, right, with all these microservices. I had a team in Shanghai for a microservices framework that I developed of 3 people managing right around 70,000 containers in production. Okay? Those containers were also running a myriad, dozens of microservices, all using the same container. So they were pushing, as we'll talk about today, they were pushing certain configurations in. Okay? And then it was, as the container came up, it was transforming what that container did in production. So even though they were running these tens of thousands of containers, they were actually running the same container tens of thousands of times to do different things. Okay? And so I think I want to talk a bit more about that once we've gotten you through the basic introduction. All right, so a bit about me. I work with organizations to overcome barriers in engineering projects. Okay? And I do that through people, process, and architecture. So what I mean by that is that code doesn't matter, right? From client to client, from project to project, the code changes, right? The framework that you're using changes. But it's really important as projects get bigger to be able to have a system that can handle those changes in code, that's slightly adaptive, right? Okay? And so Docker was the way, this was pre-Docker days, most of these projects. But we had a lot of glue code that handled a lot of the things for us in terms of launching things into production, in terms of updating stuff while it was in production that we had to develop and spend months or years even developing to be able to launch applications for clients like these. Docker in the last 5 years has kind of reinvented that. And today we're going to talk about Docker specifically and not a lot of the high-end systems that handle orchestration for Docker. So our goal is really just to write a few containers, understand what the key parts are to using a container and what is expected that, and then we'll look at a little bit about how you make a container or an image, right, that is to become a container, okay? So the first thing that I want you guys to think about is how, as we go over these exercises, how does the stuff that you're learning change how you might build an app, your last app? So think about the last app you wrote and how you wrote it and how you handled things like keys or environmental variables, if you did. And then as we start experimenting with some of these simple containers that we're going to run, how might this new knowledge impact or change the way you did that last project while it's fresh on your mind? Okay? Okay, so to get started with Docker, this is a pretty common image that you see at all Docker meetups. It tells you a little bit about what Docker is. So Docker came to be in 2013, so it's not really that new. I think it's now fairly mature. Okay, it's based on something called Linux containers. Okay, so the first version of Docker did not have huge amounts of innovation. What they did is they took this idea of Linux containers, which allowed a Linux kernel to run multiple applications with different permissions, right? Split them out and run them in different ways and be able to protect those applications even though they were running on the same server without virtualization and having to reinstall an OS for every application, okay? So the guys at Docker, what they ended up doing is they ended up building on top of that. Okay, and they ended up figuring out a way to make it more accessible through UIs, through command line tools. Okay? And just before their 1.0 release in 0.9, they actually ended up replacing the Linux container engine. So if we look at the Linux container engine, whatever engine you're using, okay? So in this example, they're looking at LXC, which is the native engine. Okay? It helps the kernel. Do we all know what the Linux kernel is? Yes? Okay? It's the core of the system, right? Okay? It gives you all your low-lying interfaces, particularly for hardware. Okay? And it allows you to run different OSs on top of that kernel, right? In somewhat the same way we used to virtualize things, but with a bit more security and scalability in mind. And so what ended up happening is when they started looking at Docker, they added a few features on top of it. Primarily this idea of an onion file system, okay? So an onion file system is a file system where as you add new layers, you can replace the files that they're replacing. So in your computer, you can think of that as, I have this folder and I have this folder and it has one changed file, and I copy and I paste all the files from one folder to another, right? Okay? And when you copy and paste those files, you choose to skip the files that are already there, right? And it will just copy all the new files on top. Does that kind of make sense? Okay? So Docker is primarily meant to run on Linux. Okay? On the Docker, the version of Docker that you have that you all have installed on your computer, on Mac it's running on the Unix core. On Windows, it's running on Hyper-V, which is Windows Virtualizer. Okay? A note for Windows users, if you're running it on Hyper-V, you cannot use other virtualization systems. Okay? So if you use any of the other virtualization systems out there that help you run Ubuntu or whatnot on your OS, and you start using Docker and Hyper-V, you'll break everything else. If you try to run those, you will start breaking your Docker builds, okay, and your Docker OS. Any questions so far? This is the boring part. We're going to get to the fun part in just a second. Okay? Yeah? Okay. Docker has two parts. Okay? It's broken out just like any other app. You've got a client and a server. Okay? The server is the daemon that runs on the system. Okay? And then here you've got the client that accesses a remote API on the server. So as you're running commands in the command line, you're hitting this daemon, and it handles building and launching all the containers locally on that machine. Okay? For the version that we have installed on our computers, they're installed together. They are usually installed together, even on servers, but that's not a requirement. You can install just one or the other, or you can install them both and just use one or the other. Okay? And you'll see that in bigger setups. For development, where you have a server and you've got a couple different ways that you can get at it from different machines, just using the client and pointing to a daemon on another machine. Okay? Once you decide that you want to run a container, it will go out and it will, much like dependency management systems, it will go get all the assets from somewhere online. It will bring them in, and it takes those images and it turns them into the container that you're running on your computer. Okay? No questions yet? Does that make sense to everyone? Yeah.
Can the OpenVZ VPS like support Docker?
Can what?
OpenVZ.
It should be able to. Docker you can run just about anywhere. You can run Docker in Docker, right? Because Docker is just a Linux. It just runs on Linux. Okay? All right, so can you guys see this code right here? Yeah? No? You need to come up to the front? Okay, so this is an example of running a couple really simple containers. Okay? I can. There we go. How's that, gentlemen?
That's good.
Okay, there we go. Okay. So there's a couple of things that you'll see here. We're going to start with the most common and required and work our way into, first of all, this container is running an Nginx proxy. Okay? The app that we're running doesn't really matter. We're just going to look at the pieces of this. Okay? So here we have essentially the repository that it sits at Docker Hub. Okay? So Jay Wilder wrote this container. Right? And for those of you that use Git, you're pretty familiar with GitHub and this naming convention, right? Here's the name of the image that we're going to use to run our container. Okay? We start with the Docker command, and we hit Docker run, and then this D flag indicates that we're going to run it in detached mode. Okay? And I'll show you a couple examples of that. More importantly, here we're mapping ports. Okay? These are the ports inside the machine and outside the machine. Okay? Because each container, you can think of it as its own little server. So if you run, say, a server, like a Node server or a Ruby server likes to run on port 3000 for development, and you wanted to expose that port to the world, and you wrote a Docker container that would house that application, you would see the 3000 inside, and then you would map it to whatever port you want it to be on the server on the outside. So your app running at port 3000 inside the container would now be accessible over HTTP on port 80, which is the default port. Questions? Okay. We're also handling HTTPS here. Okay. So for those of you that have had to set up HTTPS, it's on port 443. Okay. Next, we can name our container if we want. This is not required, but this helps us get at the container when we're running it in our local environment. Okay, so it's the -- name, and then we give it whatever name that we want. Okay. Next, we have volumes. Okay, volumes are folders from the server that you want to put into the container. Okay, so volumes allow you to share stuff from the main server to all the containers inside of it. Okay, so you can use that. In this case, they're using it for certificates, right? The Docker container itself doesn't have the certificates. The server running the container has the certificates. And so before the container starts, you need to essentially copy that folder in, right? Or share that folder between the server and the container. Okay? And then you have a couple other configuration files here. Okay? And then finally, we have labels. Okay, and these labels are just other ways of tagging containers. There's only certain containers in your cluster that require these. Okay, down here we have a much simpler one, but essentially the same thing. Okay, so we have Docker run, which is the first command that you guys are going to learn. We're running it as a daemon. We've given it a name. We've got SSH, excuse me, not SSH, HTTPS. We have HTTP, and then we're setting some environmental variables here. Okay, so environmental variables are anything that you want to pass into the container. Any questions? Because we're going to run our first container here in just a second. Okay? So, the first container I always like to write is just this little app that helps you visualize your Docker instance and make sure it's up and running. Okay? It's called Portainer. Has anybody heard of Portainer? Okay? Yeah? So, Portainer, here. Okay? Is everybody on Wi-Fi? No? Is everybody on Wi-Fi? Okay. If they're not, somebody will come around and help you. What we want to do is, you want to go to GitHub and you want to search for this. Okay. Somewhere in that, you'll see a command somewhat like this. Okay. It will give you the port that you run on. It will give you the, you can name it whatever you want. Okay, so we're going to search for portainer on GitHub. And it's going to send you probably to Docker Hub to go pull the container. Okay? So what we're going to do is we're going to together go look at that and we're going to run our first container. And this is a management panel for Docker itself that will help you manage your containers on your local machine with a visual UI. So, okay, so first we get on GitHub. This is just the way I like to find it. You can go straight to Docker Hub if you'd like.
GitHub or Docker Hub?
Huh?
GitHub or Docker Hub?
I would go to GitHub first and search for portainer. Docker Hub just uses the same README files that you have on GitHub. And I think it's a nicer interface. So we can go there. That's assuming I can get online. All right. Okay? So we can search. And it's the first project that'll come up. And then here in the getting started, you have deploy portainer. And then here's your command. I'll make this bigger so everyone can see it.
Quick start?
Yeah, under quick start. Okay, so this first command is not really needed. Okay? This is only if we want to save data, and we'll talk more about that after we run this. The main command that we want is the Docker command. Okay? After we do Docker run dp, you'll notice that the container itself exposes, like the app inside the container is running on port 9000. Okay? So it's asking you what, essentially you have to map that to a port on your own system to be able to access it. So in this case, they've chosen to just map it straight across. So it's going to grab container 9000 out of the container and it's going to make it port 9000 on your system. Okay? They've got some other things that they're setting here. Right? They're setting restart always, which we'll talk about at the end of today. They're setting a volume. So this will copy straight across and we'll discuss after the fact. Okay? And then finally, you've got portainer data and data. Okay? This is that first line that we set up right here. And then finally, at the end, you have the name of the container. Okay? So what I will do is I will give you guys a second to run it and see if you can see what happens.
It's not going to run because we didn't create the container, right?
What do you mean?
Well, you said we don't need the first command, but if we reference that in the second command.
Correct. If you want to use it, that's why I pointed out that this is the first command. Okay? So if you want, for the first run, just use them both.
Okay. Because it's cache or something, like it's inside the file system.
So did everybody get that? Who's still downloading? Yeah? It does take a while, especially as of late. Traffic between in and out of China seems to be a bit slow. Okay, so let's break that command down for just a second. So we have the Docker command, right? If you just type Docker, the first thing you should see is this list. It gives you essentially a list of everything that you can do, all right? Okay, so what we're doing is the first thing that we're doing is the Docker volume command, right? So if I type Docker volume, I also get some assistance on what I might be able to do with volume, okay? So we'll create a volume called portainer data. Okay, the next thing we'll do is we'll try to run this container. And so here's the first thing that's happening. It's telling you that this image cannot be found locally on the computer, right? Okay, the image it's looking for is this last part right here. Okay, in the last example it was JWild or Nginx, right? In this example it's portainer/portainer. Okay, so it's going to go and it's going to download that image. Okay, and the image is made up of a series of sub-images. Okay, each step that we discuss in a few minutes for building a container creates its own image. Okay, it's one of the ways that Docker becomes really portable, because if you base multiple images on the same image, you don't have to download the bottom layers over and over again. You just download the layers that you change. So as you can see here, it's downloading quite slowly. 22 megabyte container. Okay?
Can you answer the terminal a little bit?
Oh, this terminal needs to be bigger? Yeah, I can actually.
The yeah.
Gotta love hyper. Okay. Okay, so once you get this downloaded and you're running it at port 9000, you can go, and it's a web app, so you can hit it from your browser at port 9000. It will ask you, to create a username and password. You can put in whatever username and password you want. Okay? Is the first step. So you're setting up your own login, first of all. Okay? In the second step, it's going to ask you what kind of Docker instance you want to use this application to manage. Okay? So we want to select the far left one, which is local. And I will quickly do it up on my screen. Once, and you can hit next once you've selected local.
You mean connect? Connect?
Oh, connect, yes.
Do we need to run this command because it says to ensure you've started the portainer correctly on this web?
Yeah, so we're going to talk about that in just a second.
Do we run it?
No, just hit OK. Just hit connect. You've already ran it. So what this is, if you look up here, it's actually kind of cool when you start thinking about it. We have a server, right? The server is running Docker, which gives the server the ability, gives you the ability from the command line to launch containers, right? Pretty simple. But now we've thrown a container into the mix that has superpowers. Okay? This one container can now control the server Docker instance, which is the command that Brian was asking about. And it's what we did here, okay? Right here, what we did is we said, okay, for this volume, take the Docker socket on the client and mount it into the container, okay? So for those of you that are functional programmers, this is composability in a sense, right? We've pushed a function down into, through sharing folders, we've been able to give the running container access to something on the parent. Does that make sense? They are one now. Okay? And a lot of containers will do this. So once this is up and running, you should now be able to launch new containers through Portainer. Okay? The next step that we're going to do is I'm going to have you guys run a couple commands to get used to the Docker command line interface. Okay? And so if I were you, I'd write these down, but the first one is obviously the Docker command. Not hard, right? We've already experimented with Docker run, okay? The next one, we're gonna look at Docker processes, okay? Docker PS. Okay? So Docker space PS will give you
Hey, can I ask a quick question?
Yep.
So one problem I've had with Docker is it takes up a lot of hard drive space. I just installed it last night and it's already taking 64 gigabytes.
It shouldn't be taking that much. My guess is that, my assumption is that it's not Docker, it's the virtualization engine,
Okay.
right? Because it is virtualized. There's all kinds of cool stuff out there. Right, from servers that crop and change image styles for you to function as a service providers, right? If you want to run your own Lambda, right? The Iron Functions is one of the many ones out there that has a Docker container. You're up in seconds. Tired of using S3 with AWS, or are you tired of using SSO in China? You know, the blob storage systems? Then launch a Minio instance. It's essentially a server written in Go that is S3. Okay? So there's lots of little projects that you can go and find. So think about something that you've been wanting to run over the last couple months and see if you can get it up and running on your server. Or excuse me, on your machines.
So